Hi everyone, welcome to the review video for Chapter 2. You'll notice that I already have my TI-84 simulator uploaded and ready to go. If you have it handy, I would suggest pulling it out and following along with all the keystrokes as we go today. It's beneficial to be really familiar with some of the statistics menu before you sit down and take an exam, so practice with it as much as you possibly can. We'll go ahead and get started. Our first question here deals with a frequency distribution, and we want to find the class width. So we might remember that a frequency distribution in its most simple form looks something like this, where we've got the raw data binned into individual classes, and then we just count up the number of data points that fall in each class. So for example, the first class here is from 1 to 5, and I have 21 data points that fall in this class. I don't know what those 21 points are. Maybe 10 of them are 5s, 10 of them are 2s, and 1 of them is a 3. I don't know what the raw data values are. I just know that I've got 21 data points in the first class, 16 data points in the second class, 28 in the third, 13 in the last class, but we'll notice that each of these classes are the same size. The reason that is because we want to make meaningful comparisons between classes, right? If they're all different sizes, then making any observation about any one of them is really not going to do anything for us. So frequency distributions are designed so that all the classes are equivalently sized in terms of the class width. So essentially what we're finding here is the distance between one class's lower limit and the next class's lower limit. So we'll notice that between the lower limit of the first class and the lower limit of the second class, that's a distance of 5. The same is also true between the second and the third and the fourth. So our class width is just an equivalent distance that ends one bin and begins the next bin. Now, if the frequency distribution isn't given to you and you need to come up with the class width, you can use the following formula. This is something that you might want to put on a formula sheet before you begin an exam. Class width, I'll just abbreviate it with CW here, is the range, so maximum minus minimum, divided by the number of classes that you want to use. And for the purposes of this course, usually the number of classes is given to you in the problem. That's not something you need to come up with yourself. So we just divide that range by however many classes are specified in the problem. All right, number 2, estimate the frequency of the class with the greatest frequency. Okay, well, the class with the greatest frequency is going to be the bar with the biggest height, or the tallest rectangle here. So we would say that the frequency of this class is the height of this bar, which is probably right around 53. Number 3, what is the maximum data entry? We recall that this type of organization for the raw data is called a stem and leaf plot, and it really depends on how we read the key. If this is not given to us, it makes it really hard to understand the difference between the stem and the leaf. Here, the difference is literally we're separating the digits by their place value. So we're saying that this line here in the middle is separating the 10s from the 1s. Sometimes that line is not just a difference in place value, but it's denoting a decimal. Sometimes that line means that the decimal point is in between those two digits. So you really want to pay attention to how the key is set up so you don't misinterpret the graph. That's an easy way to miss points and do something silly. So in this case, the line is separating the 10s from the 1s. So if I'm looking for the maximum, going down to the bottom, my highest stem is going to be 9. My highest leaf is going to be 6. So that means the maximum data entry must be 96. The heights in inches of a sample of basketball players are shown. So 76 inches, 90, or 79 inches, 81, 78, 82, and 78. Find the mean. So I want to find the arithmetic average. I want to go through on the calculator how you use some of the statistics menus to do these types of problems very, very quickly, because most likely they'll ask you for the mean, and then they'll ask for the median, then they'll ask for the mode and the standard deviation, and the calculator can come up with all of these values very, very quickly without very much effort. So how we do this on the calculator is we hit the stat button, kind of second row down, middle next to the arrow keys. We're going to hit stat. And then we're going to hit enter on the first option there, which says edit. I'm going to put all of these heights, whoops, missed one there. I'm going to put all of these heights in a list. So I'm going to put them in L1. And lists go vertically, right? So don't go across into L2 for the second entry, go into L3 for the third entry. Make sure that these are going vertically downwards so that all of them are in the same list. So we've got 76, 79, 81, 78, 82, 78. Okay, and always scroll back through just to make sure that you didn't do a silly typo, because, you know, mixing your numbers up and writing, you know, the ones before the tens or something silly like that, just a silly typo can really throw off using the calculator correctly. So always take a second and go back through your list and make sure you copied it correctly. Now, once you have all of your data in L1, we're going to hit the Stat button again and scroll over once to the Calc menu. And the very first option there says one variable statistics. I'm going to click Enter. And if you have an older calculator like me, you need to specify which list you're doing statistics on. So here I'm going to click the second button, and then 1 to say that I'm doing one variable statistics on list 1. If you have a newer version of the calculator, you might actually get a menu that pops up that says which list do you want to use and how many times do you want to use it, the frequency, and all that stuff. So if you have a newer calculator, you don't have to worry about this, but if you have an older calculator, you might want to specify which list you're using, especially if you have a saved list of data in L1 and you put everything in L2. You want to make sure the calculator is drawing from the right data set. And we hit Enter. And it pops out all this wonderful information. It gives us the sample mean at the very top. X bar is 79. It gives us the sum of all the values in the list, the sum of all the squared values in the list. It gives us the sample standard deviation and the population standard deviation. S sub x is sample, sigma sub x is population. Now, the reason it does that is because the calculator doesn't know if the list that you entered is everybody in the population or if it's a sample. So it actually calculates both sample standard deviation and population standard deviation, just in case. N is our sample size. We can use our down arrow and scroll through some more numerical values here. The minimum is 76. Q1, which is the quartile of the first half of the information, is 78. Gives us the median, the overall sample's middle, 78.5. Q3 is the third quartile. Also gives us the maximum, and that's our last output for one variable statistic. So I'm going to use this menu to answer a bunch of questions. Number 4, find the mean. Well, that value was X bar. It was the very first one given to us, 79. So 4 must be B. Number 5. The heights in inches are given to us. That's the stuff in our list. We want to find the median. Well, I know the median was given to me, MED, somewhere towards the end there, 78.5. So number 5 is A. Number 6, the heights. Again, find the mode. Well, the mode is one thing that the calculator does not output for us. So this is usually something you have to find by inspection. It's just the data value that appears most often. So the height here that reoccurs is 78, so it's got to be D. All right, now number 7, find the standard deviation. Now here, this is where I have to, again, kind of depend on context clues to figure out which value I should report. Since it specifically says that this is a sample of heights, that means that the output from the calculator I want to take is S sub x. S sub x is for sample standard deviation. Sigma sub x is for population standard deviation. Since this is a sample, I want the S sub x value, and that will round to about 2.2. It's on the calculator, it's 2.190890023. That's going to round for A. If I had chosen C, that would be wrong. That would be population standard deviation. All right, number 8. The mean annual automobile insurance premium is $950 with a standard deviation of 175. The data set has a bell-shaped distribution. Okay, I'm going to use that to my advantage and copy down the information that's already been given to me. So I'm told that I've got a nice bell-shaped graph. and I'm told the mean is 950. So in a symmetric distribution, the mean sits on the line of symmetry, which will be right here. So 950 is my mean, and I'm told that I've got a standard deviation, sigma, standard deviation, of $175. Okay. Even before I go into the rest of the question, this is enough for me to finish setting up the rest of my graph. I know it's bell-shaped, I know the mean, I know the standard deviation. That means I can also set up all of my standard deviation markers left and right of the mean. This will allow me to use the empirical rule if I can. I can't always use the empirical rule, especially if it's asking me about an insurance premium that's not one of the standard deviation markers. But if it does, and I already have the graph set up, then I can just pull the information right from my picture. Okay, so I'm going to set up all of my markers left and right of the mean. If I go one standard deviation below, meaning 950 minus 175, I'm down at $775. If I go two standard deviations below the mean, meaning another difference of 175 from this marker, then I'm down at 600. If I go 3 standard deviations below the mean, that puts me down at 425. I can do the same thing to the right. 1 standard deviation above the mean is going to be 950 plus 175. That puts me up at 1125. 2 standard deviations above the mean puts me up at 1300. And 3 standard deviations above the mean puts me up at 1475. Okay, and again, this just comes from subtracting the standard deviation and adding the standard deviation to the mean. Okay, now the question is asking me to estimate the percent of premiums that are between $600, and I'll change my color here, between $600 and $1,300. I want to estimate the percent or proportion of people that are falling in this automobile insurance premium range. Okay. Well, it just so happens that $600 premiums and $1,300 premiums are exactly 2 standard deviations below and 2 standard deviations above the mean. Those are falling within the range of my empirical rule, which says the following. The proportion of data for a bell-shaped distribution that falls within 1 standard deviation of the mean is 68%. The proportion of data for a bell-shaped distribution that falls within 2 standard deviations of the mean is 95%. The proportion of data points that fall within 3 standard deviations of the mean for a bell-shaped distribution is 99.7%. So a lot of times the empirical rule is called the 68, 95, 99.7%. The first percentage is for 1 standard deviation away, the second percentage is when we're 2 standard deviations away, and the third percentage is when we're 3 standard deviations away. Well, 600 and 1300 are exactly 2 standard deviations above and below the mean. So that means that we are in the 95% part of our empirical rule. So I'm going to answer C. Number 9, use the box and whisker plot to identify the first quartile. Okay, well, the 5-number summary is what we use to set up the box and whisker plot. It is our minimum, maximum, those are the whiskers, and then it's the interquartile range, IQR. The interquartile range is the difference between the 3rd quartile and the 1st quartile. So that's essentially the box part of our graph. So this number here is what we call Q1. The middle value here is what we call Q2, or the overall median. And the last value here is what we call Q3, the 3rd quartile. This is the median of the upper half. Q1 is the median of the lower half. So in this case, if I want to find the 1st quartile, that must be at 18B. All right, last problem here. Number 10, the mean annual automobile insurance premium is $950 with a standard deviation of 175. So from a previous problem, we've already identified this as a bell-shaped distribution. Mean 950, standard deviation 175. Notice how I'm taking down all this information as I read it. If I have given information and I'm told something about the distribution, I make note of it even before I start the problem, so I know exactly what I'm working with. All right, the question here is to find the z-score that corresponds to a premium of 1250. Well, 1250 would be up here somewhere above the mean. So I already know that my z-score is going to be positive. Quick review, the z-score refers to the number of standard deviations a data value is above or below the mean. So it's a way of measuring position, basically in reference to our measure of center, right? So where is some other data point in the distribution in reference to our middle, right? To our measure of center, the mean. So in this case, because I already know that 1250 is above the average, I can eliminate B and D as possible answers because I know the z-score is going to be positive. It's above the mean. Now, how we calculate it is with the following formula. Z is the data point minus the mean divided by the standard deviation. So in this case, the value that I'm interested in, the premium, is 1250. The given mean for this distribution is 950. And I'm going to divide that by my standard deviation, which is 175. Okay, so let's do that on our calculator real quick. 1250 minus 950. And that difference, 300, I'm going to divide by 175. So all the way out, 1.714285714. Calculator holds 10 significant digits. It looks here like I'm rounding to the nearest hundredth. So 1.714 is going to round to 1.71. I'm going to say C as my answer. Okay. Now, that's the end of our questions for Chapter 2. Again, I can't cover every single tiny little detail from Chapter 2, but this gives you a pretty good idea of the types of questions and concepts that you really should know to be proficient on this chapter's material. So hopefully that was illuminating for you. Get some good practice using the stat edit buttons on your calculator to work with lists and calculating one variable statistics. If you have any questions about any of the problems here, don't be afraid to email me, and I will see you in the next video.